we're going to talk about transformations of logarithmic functions. All right. So hopefully you recall the basic log graph, right, which I have right here, that has a domain of 0 to infinity, a range of negative infinity to positive infinity, and it has a vertical asymptote at x equals 0 and an x-intercept at 1, 0. And again, the reason that it had an x-intercept at 1, 0 is because any number to the 0 power is 1, right? And when you're finding a log, you're actually finding the exponent. So the y value is the exponent that would give you 1. So 0 is the exponent that would give you 1. All right. And then just another little note here, because we've been doing our arrow notation. This vertical asymptote at x equals 0, this is here because as x approaches 0 from the positive side, right, you can't approach 0 from the negative side because it doesn't exist over there. So as x approaches 0 from the positive side, y approaches, it goes down to negative infinity, right? And we remember that that was the definition of a vertical asymptote, right? If one of those four things happens, if it either approaches negative infinity as you look from the right or as you look from the left, or approaches positive infinity as you look from the right or you look from the left. Okay, so that was the definition of a vertical asymptote. So this happens to be the graph of y equals log base 2 of x, right? So it has the point 1, 0 on it. Then this point here is going to be 2, 1. Then you have 4, 2, and so on and so forth, right? So I guess your x here is going by 2's and your y's are going by 1's, right? So that's actually 1 there, 2, 3, 4, so on and so forth. Okay, so now we're going to look at transformations of this graph. So I have various transformations here graphed. So the red graph is the original, and the other colored graph is going to be the transformed graph. Okay, so if we look at this one here, we can see, all right, well, this point on the original graph became this point on the new graph. This point on the original graph became this point on the new graph. This point on the original graph became this point on the new graph. So what happened here? That was what you would call a reflection in the x-axis, right? And remember, what was a reflection in the x-axis? It was when you actually did negative f of x, right? Because you basically took the opposite of y. So this graph here would actually be negative f of x, right? If we're thinking of f of x equals 2 to the x. So in this case, right, let's go back up here and call this graph f of x, I guess, right? This is f of x, which is log base 2 of x. So then this one was a reflection in the x-axis, which was actually negative f of x. And then if we wrote it in terms of x, it would just be negative log base 2 of x, right? So that was a reflection in the x-axis. So if we look at the one to the right here, we can see the reverse happened, right? This point here became this point here. This point here became this point here. This point here became this point here. So you can see this was a reflection in the y-axis. So this graph here is actually going to be f of negative x, which is going to be log base 2 of negative x. Okay, and just some things to note about these new graphs now. This one here, log base 2 of negative x, the new domain here is actually negative infinity to 0. The range is still negative infinity to positive infinity, but, and the vertical asymptote is still x equals 0, but here the distinction is as x approaches 0 from the left side, y approaches negative infinity. So that was the difference in this one, right? In the reflection in the y-axis. Now the reflection in the x-axis, the domain and range are still the same, right? Domain is still 0 to infinity, range is still negative infinity to infinity, but the distinction here is as x approaches 0 from the left side, you can see the purple graph goes up to infinity. I'm sorry, it's from the right side. As x approaches 0 from the right side, y approaches infinity, right? So it just goes up instead of going down as you approach 0 from the right. So those were your reflections. And then these bottom two, let's see here. Okay, well this one here, this green one, it looks like you were here and then you went down, and here you went down. But in this case, the y, you can't see the scale here, but the y is scaled by 2, just like the x is scaled by 2 in this case. So here you can see that this was actually a shift 4 units down, right? Because I went from the point 4, 4 to the point 4, 0. The point 8, 6 to the point 8, 2. Actually, no, that doesn't make sense. This is the y-axis is actually scaled by 1s here, because it wouldn't be 8, 6, it would be 8, 3. So this also goes by 1s. So this wasn't a shift down 4. This was only a shift down 2, I guess, right? Because the point 8, 3 is on the original graph. That's the point 8, 3, because log base 2 of 8 equals 3. And that point became 8, 1. This point here, which is 4, 2, became 4, 0. So it actually was a shift down only 2 units. So yeah, this was a shift down 2 units. So how would we write a shift down 2 units? We would say it's f of x minus 2, right? And this is easy enough to write. It's just going to be your log base 2 of x minus 2. Right? So that would be your green graph, log base 2 of x minus 2. And then this one, I think, is a little bit easier to see, because you can see the original point on the red graph we know is 1, 0. And that became 5, 0. So where's another one I can do? 4, 2 became 8, 2. So in this one, you're actually shifting right 4 units. So when you shift right 4 units, that will be written as f of x minus 4, which in this case is going to be the log base 2 of x minus 4. So there's 4 transformations of the logarithmic graph, right? And again, some more things to note here. This one still has all the same behavior, right? Just shifting it down didn't change the vertical asymptote. It still has a domain of 0 to infinity. It still has a range of negative infinity to infinity. And as x approaches 0 from the right, it still approaches negative infinity. Now this one, since you shifted it 4 units right, the original asymptote, which was at x equals 0, now gets shifted to x equals 4. So this one actually has a vertical asymptote at x equals 4. And then what's the behavior around the asymptote? As x approaches 4 from the right side, y goes down to negative infinity. Okay, so there's 4 transformations of the logarithmic function, right? We have a reflection in the x-axis, a reflection in the y-axis. We have a shift down 2 units, and then we have a shift right 2 unit. Right 4 units.